Hello guys, in today's video we're talking about implicit differentiation. Implicit differentiation is another method of differentiating. Now we want to know when you are going to use implicit differentiation. So we use implicit differentiation on implicit functions. Now let me explain what implicit functions are. You have been differentiating functions like y equals to x squared plus 2. Something like this. You have been differentiating functions like this. These functions are called explicit functions. Now, why are they called explicit functions? They are called explicit functions because y is expressed with respect to x. So when we are differentiating in these explicit functions, we differentiate y with respect to x. But for implicit functions, we differentiate x and y at the same time simultaneously. So we have x squared plus y squared plus 2 equals to 5. This is this is an implicit function. So anytime we are differentiating, we differentiate them simultaneously. So the method of differentiating an implicit function is called implicit differentiation. So now let's go into solving implicit differentiation. So before we start differentiating, there are some rules that you need to take note of when using implicit differentiation to differentiate. The rule is that normally we differentiate x normally, but when we differentiate y, we attach the y dx to it. That is the rule. So let's go now. Differentiating x, what do we have? This goes here, we have 2x plus differentiating y, we have 2y. Now we attach the y the x, which so that we are going to follow the rule. What do we have? Times the y the x plus. These are constants, so we have 0 equal to 0. So we are left with 2x plus 2y the y over the x equals to 0. Taking this one here, we have 2y the y the x equal to minus 2x. So what do we have now? We have the y dx dividing 2 by 2y equal to minus 2x all over 2y. So this cancels this. We have the y dx is equal to minus x all over y. So this is the final answer. Now let's go into solving more problems on implicit differentiation. Suppose we have an implicit function like this. What are we going to do in this case? This one looks more complex. So we are going to look at the function very well before we differentiate. Now looking at this, we find out that x is multiplying y. So what comes into our mind in this case? We are going to use product tool in this case. Using product tool. Now let me take you back to product tool. Suppose we have something like y equals to x squared times x plus 3. The easiest way to solve this using product tool is just this. When we have the y the x is we leave this as it is. That is, we keep it constant. We don't differentiate this one first, but we differentiate this one. Differentiating this one, what do we have? X. We have 1. So this one, the differentiation of this one times this one, which was not differentiated, plus the differentiation of this one times this one that has not been differentiated. So we have 2x times x plus 3. So this is the easiest way to solve using product tool. Since we have equation like this, we are not going to start going to the normal process of solving product. We are just going to use this shortcut to solve it. So now, using product tool on this, we are going to leave this constant and differentiate this. Remember, when we differentiate y, we always attach the y dx to it. So leaving this constant, we have x times differentiating y. What do we have? 1 times the y dx plus the plus. Now we are still on this, so we are now going to differentiate x and leave y constant. What do we have now? Differentiating x, we have 1 times y. We didn't attach the y dx because we didn't differentiate y there. So now we have plus differentiating this, we have 4y the y dx plus differentiating this, we have 3. This is a constant, we have 0. So what do we have now? We have x the y dx plus y plus 4 y dy dx plus 3 equal to 0. So collecting like terms now, we have x dy dx plus 4y dy dx plus y plus 3 equal to 0. So we'll take this over here. We'll take this 2 over here and leave these ones with dy dx on the other side. So we have x dy dx plus 4y dy dx. Taking this over here, we have minus y minus 3. So now, we are now going to factor out dy dx from here. So factoring out dy dx, we have dy over dx into x plus 4y equal to minus y minus 3. So dividing 2 by this, so that we'll be left with dy dx. Now we have dy over dx is equal to minus y minus 3 all over x plus 4y. So this is our final answer. X square y square plus 2y square equal to 6. And we are meant to differentiate this. So normally we are going to use implicit differentiation since we are differentiating an implicit function. So looking at this, x square and this is a product of x square and y square. So what comes to our mind? We use product rule. So using product rule, we keep this constant and differentiate this first. So we have x squared times differentiating this, we have 2y. We have 2y. We attach the y to x because we have differentiated y plus. Now differentiating this and leaving this constant, we have y squared times differentiating this, we have 2x plus differentiating this, now we have 4y equal to 0. No, differentiating this, we have 4y dy dx. We always attach the y dx when we differentiate y equal to 0. So now we have x squared 2yx squared dy dx plus 2. Okay, let's use here x squared 2y, or let's use 2x squared 2x squared y plus 2xy squared plus 4y dy over dx equal to 0. So now we collect like terms. Carrying this here, now we have 2x squared y dy over dx plus 4y dy over dx equal to minus 2x squared xy squared. So factoring out the y dx, what do we have? The y over dx into 2x squared y plus 4y equal to minus 2xy squared. So we have our dy dx to be equal to minus 2x squared xy squared all over 2x x squared y plus 4y. So this becomes our final answer. That is it for implicit differentiation. I hope you enjoyed this video. Please don't forget to like, share, and subscribe. Thank you for watching. I'll see you in my next video.